Thank you very much, guys, for choosing this talk. I know there are like other talks to choose from. Thank you very much. Make the impossible possible and make the possible elegant. That used to be the favorite saying of Hans, the father of Gradle, when he described Gradle. Now it's about developer productivity. But like for us, using Gradle for Play framework at LinkedIn was like a mission impossible. Especially last year at the time when 2 engineers allocated to Play on Gradle productivity at LinkedIn, they left for good reasons, not because they didn't want to work with us. One pursuing like much bigger role, the other pursuing much shorter commute and doing the internal transfer to San Francisco office. But we were in trouble. Like we thought that it's not gonna happen, but it happened. We have more than 30 applications, Play framework applications built and tested and deployed with Gradle, and it's working really well. This is the story how it all happened, and there's fantastic engineers that made it happen. I was just basically just helping out a little bit. So it was a difficult, interesting problem. Why? Our team is small, LinkedIn is large. The biggest of our applications, those that generate most of the revenue, they are built with Play framework. They are essentially Play apps. Those applications must work. The build should always work. From commit to production, there has to be less than 3 hours. Like every time there's any trouble in the build pipeline, this is like a big deal at LinkedIn. Like, people are being called. Like this has to work. And Play comes with SBT, like this extra complexity. And especially those big applications at LinkedIn, they had that complexity. Like engineers develop various things to get those applications running. And our work to replace SBT, like the engine behind like building and testing Play framework applications with Gradle, it had to work, it had to stick. We had to find ways to make it safe to roll it out at LinkedIn scale. That was very interesting. And we want to share the lessons learned from that journey and how we made it happen. SBT is, I'm sure there are like good use cases that demonstrate that SBT is fantastic build framework, a build tool. Maybe there are even use cases when it shines better than Gradle. I have full respect to engineers behind SBT. I make tools for engineers, so I know it's hard to do them right. Most of the use cases at LinkedIn were telling us that we should replace SBT with Gradle. That's what we have been doing with big success. Play framework at LinkedIn, it was introduced around 2012, 2013, but why? Why did we do that? We believe that it can address certain problems that we've seen with traditional like web application development for the JVM. We wanted to avoid the thread pool hell problem, where in the traditional web server technology for Java, you would have a fixed amount of threads for each web server, and each thread would be basically serving one request. And if that request triggered business logic that needed some information from your mid-tier, and that triggered another request for getting some stuff from the database, like that top thread that was basically operating that request would block and wait for all those operations. And then what you can have is at big scale for large apps, you can have latency spikes that basically can creep and overcome the entire system, and then boom, your site might go down even if in some really like bad scenarios. And like site up is like fundamental for like business like LinkedIn. It's like oxygen for humans. It's like the site has to be up all the time. Another big reason why Play framework was introduced was hot reload. And the hot reload in Play framework is very hot. It's best in class, especially at that time. Nowadays, the hot reload has been adopted to many web frameworks. The basic idea is that the engineer should be able to write code and implement a feature and then immediately see how that code change is reflected in the behavior of the application, the web application. So he jumps from the IDE to web browser and he can see those changes reflected. And those cycles have to be really fast in order to get like maximum productivity. And at LinkedIn it's super critical because we have hundreds of developers developing with Play framework. So even seconds of that hot reloads are really meaningful for us and can translate into like nice $1 million digits if you consider like the entire organization. We also believe that Scala is an interesting language, modern language, potentially could replace Java, help us build applications faster. That wasn't such a good idea. At this moment at LinkedIn, we don't recommend using Scala for developing Play framework applications. We have a strong recommendation not to. We have some old code with Scala related to Play framework. We have certain little bit of a layer here and there in some of the applications where Scala was needed to be used. And Scala in general have its use cases. It's very strong in the offline, in the big data world. For Play framework at LinkedIn and for developing libraries, we avoid using Scala. And I'm not going to get into too many details, but I want to mention that it's interesting. We do actually develop with Java Play applications, and we do it very successfully. Although Play comes from the Scala community, it is very open to Java, and the APIs are really good to use nowadays with Java. Now, Play has this one gotcha that comes with SBT, a build system that is called simple build system. I have no idea why it's called simple. If you think that Gradle learning curve is steep, don't even try SBT. It's using every single possible feature of Scala. Yeah, I think I'm gonna give it now to Gary. He will tell you more about history and about SBT and about other interesting things. Thank you.
Hi. Hello? Can you hear me? Okay, so just kind of curious, how many people are actually using Play? Show of hands. Okay, some. Okay, cool. Okay, it would be cool to use Play. I really like Play. And a little bit background about myself. I'm actually coming from presentation infrastructure from LinkedIn. And Play is one of the framework that we are primarily responsible of. And a little bit history about the Play at LinkedIn. Back in 2012, we see Play as a really potential framework. So we take the open source code into inside LinkedIn, and we start building, trying out with different apps and trying to do prototype. And until 2013, where we got it into kind of like a working stage, we start ramping application, we start getting application engaged to, start using Play. And up till today, actually, we have about 200, Stefan already covered it. We have over 200 applications using Play at the moment. To give you some idea, like number usually doesn't give you too much idea, but to give you some idea, if you go to linkedin.com today, most of the front-end server that actually serving all our production traffic is actually powered using Play. And that's how commit we are with the Play framework. And Play is really cool. I mean, I like Play, and Play has a lot of nice features that we start getting application adapt to it, but then we start figuring out, well, application become more complicated, our code become more complicated. Things doesn't look that cool anymore. Hard reload, yeah, it's supposed to be really hot, but it's not that hot. It's getting cooler, and sometimes it's getting cold. We got some application, to give you some idea, we got some application that take probably 2 or 3 minutes to do a hard reload. It's horrible. And then we also run into a lot of dependency management issue. And a lot of this issue, we try to contact TypeSafe, which is the people who are kind of responsible for SBT. And unfortunately, we didn't get too much out of it. I'm going to talk a little bit about the SBT challenges. For SBT, we had, again, dependency management is a big issue we have with SBT. Not just what I have already mentioned, it's really, really slow. And at the same time, it also doesn't work. Sometimes dependency doesn't get resolved correctly, and we need to do patching. And if you look, resolution is kind of bad. If you look up there, we have a Stack Overflow exception. This is actually something we got recently. And I have to tell you a cool story about that. And so we got this application team. What they did is they take their app, they bump up one of their dependency, and suddenly everything blow up. And if you can read, this is actually all coming from SBT, right? And we try a lot. We actually contact TypeSafe. We say, help us out. And we do a lot of debugging. We even dig into the SBT code, but we couldn't really figure out exactly what blowing up. So this one person from my team was kind of suggesting me, usually when you get to this type of problem, it must be a configuration issue. You must have some circular dependency. Although you only bump one dependency, but this dependency must bring other dependency, right? We're a good engineer. That must be the issue. So he said, well, SBT probably work. It's just that, unfortunately, it blew up, and it doesn't show a nice message. So he said, well, since you're working on trying to pull play into Gradle, just test it out. So I take the whole project and move to Gradle. Guess what? Gradle worked perfectly fine. We don't see any issue. That kind of gives you an idea about what kind of issue we encounter with SBT, and a lot of time we have to patch, we have to work around it. The other problem we encounter with SBT is a lot of application developers come to us and say, I want to do certain task, but I don't know how to do it. I just don't, this whole thing doesn't look intuitive to me. And what SBT actually does is take the Scala as a base language, and you try to build some sort of DSL language on top of it. Unfortunately, it's not so intuitive, and people just have hard time to understand it. And I think the most fundamental issue is SBT community is not as big as Gradle. So usually people run into issue, they go to internet, they search around, they ask questions, they can find similar issue other people has. But we couldn't really do the same thing as SBT, and our team, actually the primary team, actually taking on most of the support for the Play framework. So you can kind of feel my pain. And if you're kind of wondering why there's a lot of emoji there, it's actually not emoji. That's kind of like the SBT way of presenting different type of operator. That kind of gives you some idea how tough it is to understand this type of languages. So when things doesn't work, guess what people do? Play with SBT, but now I want to do certain thing. It doesn't work. What do we do? I heard about we can use Gradle, right? So let's use Gradle. So actually, some application teams start instead of doing a SBT plugin, they start doing Gradle plugin. They say, hey, I can make SBT code Gradle. And the more they do that, the slower our whole build time becomes, and it becomes worse and worse. And that's the whole reason that not only the build is slow, and also hard reload is slow. So very obviously why we moved to Gradle. And dependency management, Gradle is much, much better on dependency management. Not only is fast, it's efficient, and it's also a lot of time it's running correctly, not like SBT, right? And the other big thing I forgot to mention with SBT is our developer has a huge problem with getting SBT project into IntelliJ to work. Importing a project, sometimes they need to wait, again, about 30 minutes to get their working space all loaded up correctly. And if they're lucky, it loaded up. If they're not lucky, well, they see an exception and everything blow up, well, we say, maybe just do a clean and try again, right? And that's how painful it is. And the other thing is do infrastructure. Linking, although we adopt Play framework, but we still have a lot of other infrastructure which are still building using Gradle. And we already have a lot of things. We already really committed to the Gradle technology. So keeping SBT and Gradle, two things at the side, it's very, very difficult. So every time when we need to come out a new feature and new infrastructure, we need to do a SBT plugin. At the same time, we also need to do a Gradle plugin. So it's a lot of redundant work. And the whole concept of moving Play to Gradle is we want to actually turn linking into a Gradle dynasty. So we want to use a single building tool, and we want to be consistent. And it's not only is a lot easy to manage, and a lot of times when we want to do certain optimization, we can do it uniformly. And of course, we have really good partnership with Gradle Inc. And we sponsor a lot of work. We sponsor a lot of work to Gradle and ask Gradle to help us to work on it. And we also contribute a lot to the Gradle open source community as well. So when we actually had this idea of moving Play to Gradle long, long times ago. since 2014. We sponsor the Gradle Inc. They help us to implement a plugin, Gradle plugin that will actually work with Play. And around 2015, we got the open source implemented. And like Stefan already mentioned, unfortunately, we have some resource shift. We didn't get to work on it until 2016. Actually, late 2016, around Q4 in 2016. And when I first joined the project, people tell me this project is going to run till 2018. So they say, well, this is going to be very, very difficult. You have like over hundreds of applications you want to migrate. People have different, we not only have a lot of legacy Gradle plugin, we need to integrate, and also different applications have different use cases as well. But guess what? We actually beat our schedule a lot more than what we expect. We're actually getting our Play on Gradle not only working, but even some application deployed in production in 2017. So how do we do it? When we actually pick out the work in 2016 in Q4, this is the approach we take. Like, we didn't take the traditional approach. Usually what you do is you got like a few engineers sitting down and say, hey, let's imagine like, all the use case. Let's make a huge, like, nice, framework. Let's architect all this out, do a lot of whiteboarding, all right? And we say, well, we don't have that much people, like, and also there's a whole bunch of different type of app in linking. How can we do that? So, and also like by the time we finish, like doing all this planning, doing all this implementation, it's probably a few months passed by already and people don't actually see anything. So we say, what's the best way to do it? Maybe we should do it in a more agile way. We should do some more, rapid prototyping. So what we do is actually we say, let's take a simple application. We know like actually Gradle Inc. already created this nice plugin. Let's just kind of integrate and see what happens. So we take a simple application, we got things integrated, and we say, let's not writing any single line of nice code. Let's just hack this thing out in the fastest way, get this damn thing to work, right? So we take a simple Play project and we hack it out. And I can tell you it's really, really ugly. We got like our build.gradle file is about 2,000 line long, and it's totally ugly. There's a whole bunch of hard coding. But it actually works. It is something we can actually build the thing, and we can actually run the thing, we can deploy the thing, right? And so what we actually do is we start taking this totally hacked thing, and we start showing off to people. And at the same time, it actually helps us to compare the metrics. So we can see, by using Gradle and compare with HBT, like what kind of advantage we can get. Like later on in the later slide, we will have a lot of metrics to show the actual performance gain. But having to do this type of rapid prototyping helps us a lot. In many aspects. So we actually explore and we understand all the unknown upfront before we actually writing a single line of like actual real production code. So what we do is we take this 2,000 line of ugly build.gradle file and we start kind of dividing into each individual tasks. We say, okay, I know like how we hack this. These are all the issues, and how do we convert them into tasks? How do we actually engineer properly? And while we're doing that, we say, well, we did a simple project. Let's try something even more complicated, right? So we take something more complicated, we say hack it again, right? So we actually take the work stream in this we actually create this two work stream. One work stream is we keep trying to convert the unknown into something that's a more fundamental infrastructure, more production ready code. And we take another work stream, we keep like finding out new problem, and we feed it into this this kind of list of tasks. And we continue doing that, and during the process, we show off to people and we demo to people. And guess what? Like we got application teams so excited. Like a lot of people say, whoa, this is great. Like this is gonna help us our productivity a lot, right? And we even have application team come to us and say, I want this now. I know this is the old hack, but I want it now. Like what can you do, right? And so getting this kind of nice feedback actually help us a lot. And at the same time, instead of actually say working all by ourselves, we work with our customer, which are all the application developer. And also we tell them, well, if you want this to be available much sooner. How about let's just join our team? That's kind of help us out, right? Always been as a developer, I have always been told, you should listen to your customer. You should work for what your customer wants. But I think we changed the paradigm quite a bit. We say, don't listen to your customer per se. Don't do the work for customer. Bring customer into your team and have them work with you. So that's exactly what we did. We actually partner with multiple application teams, and we do join force, and we get buy-in from the management team. We say, once we accomplish this, it will actually help your productivity tremendously. And once we got the buy-in, we grew from 2 people all the way to 5 people, and right now there are still people who want to sign up to actually work within this team. And in a way, I think this is a great lessons learned for a lot of people. If you have a really, really complicated infrastructure, or if you're already using some legacy build system, right? If you want to switch it to a much more performant, build system like Gradle, this is probably an approach you should take. You don't want to say you design all this thing and then let's figure out migrate one by one. You want to actually do the rapid prototyping upfront, and also get a number, show off to people, and also partner with people. Because I figure out at the end, we learn a lot of new things. I think when I joined the project, I was imagining this is, actually, because I'm coming from the because I'm coming from the presentation infrastructure team, and we maintain Play framework, we work with application team from day to day. We think we understand how application team do things. But at the end, it didn't turn out to be that way. A lot of things we see, this is typical how people are going to do build, how people are going to run their application, but it's not exactly true. So we also learn a lot from application team during this process. And of course, the last point is also actively engaging with the open source community. Actually, during this process, we define bugs with Gradle, and we create pull requests. And there are also certain things in the Play plugin, we find out we actually need additional feature, and we also work closely with Gradle in folks and trying to sponsor them and actually work on this. And actually, we're hoping once we go through this whole hurdle, we will be able to kind of ship the Play Gradle plugin into something that the entire community can use. So hopefully, if you're using Play framework today, or if you're planning to use Play framework in the future, hopefully you won't suffer from what we're suffering. So I'm going to hand over to Yiming to talk about our application in production and what is it like.
Hello. So the major big news in 2017, let's talk a little bit about the technology details. So Play on Gradle is officially shipped in production, which means that Play on Gradle is really the real deal. So let's talk about a little bit about the Play use case inside LinkedIn. So of course, first we have something called Pemberly, which stands for Play plus Ember.js. And then it's called Play mid-tiers, and then third is called Play frontends. Basically, that's actually the way we try to migrate things. We first migrate Pemberly first, and then mid-tiers and frontend. I'll talk a little bit about why we do things in this order. So the Pemberly is Play plus Ember.js. So Ember.js is a JavaScript framework that actually builds all the JavaScript and also the HTML, basically all the assets. So why we need Play actually to pair with Ember.js is because we build all the assets, we need a Play server to serve them, right? So in this case, it's more like a hybrid application. So it's kind of innovated by LinkedIn. And also why we first prioritize this kind of application is because first, it's very high impact. So actually, LinkedIn.com is on Pemberly. Let's say this front page is on Pemberly. It's a Pemberly web application. And also, actually, since it's a half-half application, actually the Play part of this application is fairly standard. All the Pemberly web share similar Play structure. So if we can make it work, we can easily apply them to all the Pemberly webs. Actually, that's what we do. And then we'll talk about the Play mid-tiers, why we prioritize Play mid-tiers. Secondly, it's because actually it has the most value in the speed gain. Why is that? It's because Pemberly is a Pemberly web mostly, which means they have many assets. You have many assets. That means you have someone to compile it for you, like JavaScript or Dust. That means even you use Gradle or SBT, you're going to call out to the asset compilers, which means even you use Gradle, you're not going to get a huge gain in speed. On the contrary, if you're using mid-tier, which is very light in asset, it's just fetching all the JSONs back and forth, you don't have any asset. It's very light. That means by using Gradle, you can enjoy the full benefit of dependency resolution and all kind of stuff. Actually, the gain in the speed is the most. That's why we actually also prioritize play mid-tiers, because we see the most value in it in the speed gain, especially. So the third type is play front ends, which is more like traditional front ends. It's using, for example, using Dust. So, and also, it's kind of being replaced by more modern web structure like Pemberly. And also it's very highly diversified, and also it's very asset rich. So the gain in the play on Gradle migration will be slightly lower. That's why we kind of make it the lowest priority. That's why we mark it as an asterisk. We just start shipping those in production, but the first two categories, we're shipping plenty of apps in production already. So let's talk a little bit about Pemberly specifically. So if you look at the picture, so we can see that basically the Pemberly is a modern web structure. It has 3 layers. You have the first layer is the entry point. So the web means it is the desktop entry point. When you click linkedin.com on your laptop, that's where you land. So, and also, of course, you have the Android and the iOS as a mobile entry point. And then these are all like the front ends we have. And then what they do is they call out to all the API server, which is also kind of mid-tier, but it's front-end facing mid-tier servers. And then one layer down is the API server we'll call the mid-tier servers, which is more like internal server. They're using REST. And then looking at that picture, you'll be able to see that how many play that's in this picture. The play is so pervasively used in LinkedIn. And if we concentrate on the top layer, which is a Pemberly web, so we can see there's play plus Ember.js. As I explained, that means Ember.js built all those assets and then served by a play server. So how does it work out in the development workflow by hundreds of web developers at LinkedIn? So we once did a statistic count that we have like 300 like web developers at LinkedIn. So what they do, how is their development workflow look like is that they change all their they mainly change the assets like JS, right? When they change the JS, they're going to build them and serve by a play server. They are going to launch a play server right on their machine and to render it on their browser locally. So they can locally test, which means that's basically what the Pemberly workflow is. So play server is the key part to serve all those assets that they edited. And they also utilize the hot reload functionality of play and Ember, so you can get really, really fast iteration and fast feedback. So typically, when we use SBT, typically the play server launch will cost like probably 2 minutes. So by using Gradle, we can drastically improve its speed like less than 1 minute. So which is pretty big deal for all our 300 UI engineers or front-end developers. And then that's why it's really well received by all our, especially the front-end engineers. And we are very glad that actually more than 3/4 of the web dev workflow have been migrated to Gradle. And also all those packaging stuff is also done by Gradle, and they are all shipped to production. I just want to name a few. Is, for example, LinkedIn.com, the front-end page, and also LinkedIn Salary, LinkedIn Learning, LinkedIn/Learning, LinkedIn Salary, LinkedIn Post. All those are already packaged by Gradle, and all those dev workflow has been migrated to Gradle. So taking about some numbers. So as Stephen said, we have around 270 or 300 apps at LinkedIn. So we have total about 5,000 apps/libraries at LinkedIn, which means they only comprise about 5% of the total number of apps at LinkedIn. So by saying that, I'm really not trivializing our work, is because, as Stephen also said, these are all the revenue-generating customer-facing apps, and they really cannot break. So they are really, really important. And also, just name a number. They're sitting on the top of the food chain. They're consuming all kinds of libraries. Just to name a number, one of the mid-tiers, actually, the direct dependency, they have like 400 direct dependencies. So, which is huge. And those like dependency resolution is really complex. And all the build time, they really suffer. If we look at the numbers, the median number for LinkedIn library / app, the build time is about 10 to 15 minutes. But however, for a Play server, if it's, for example, LinkedIn jobs, the front end will build, it will cost like 1 hour. And then if you plus all the tests, it will be 2 hours, which means they're really, really complex. So, and that's why the Play on Gradle is going to solve those problems, that's why all those people are coming to us saying, how can we help? So, and then the final number is like we have already 30 plus apps migrate to Gradle and deploy to production. And they have 3 parts. The first part is all kinds of prototypes. That's something we try to migrate first and then make sure nothing breaks, the fast prototyping. The second part is we try to migrate all the all the apps that cover the most use case for us, which means, for example, this app covers integration tests. That app covers Avro, for example. So by migrating those apps, actually we have covered most use cases. That paves the way for us to migrate almost all of them because we know that they all kind of can be migrated. So the third part, of course, is for early adopters. Some organizations, they were trying to volunteer. They said, okay, let us be the guinea pigs, right? So for example, the LinkedIn Learning, which is really awesome. Zach is going to talk about, he's from LinkedIn Learning. They have their Pemberly web and also Meteor is fully migrated. So basically, there are 3 types of apps that are migrated. So, and we are expanding more, and the number is rapidly growing. So, and then I'll hand over to Vinyas to talk about some of the learning we have in the migration process.
All right, thanks, Yiming. Hi, I'm Vinyas. I work for the productivity engineering team on LinkedIn. So what we are tasked with is basically making engineers more productive, allowing them to write code faster, better, and get it into production sooner. So I'm going to talk a bit about the things that we learned along this journey and some best practices that we have in place. So let's start off with the learning curve. How did we learn Gradle? Personally, I felt that Gradle online training was really useful. Gradle also has some really great documentation. And fortunately for us, we had some really good Gradle experts in-house. So that really helped us learn Gradle faster and better. And even though the Gradle learning curve is pretty steep, but once you get over that whole configuration versus execution phase hill, it becomes slightly more simpler. And Gradle being open source allowed us to basically dive deep and find out how it worked behind the scenes. When we encountered issues that were not within the scope of our code, but actually resided in Gradle, since Gradle itself was open source, we could debug it, figure out where the issue was, fork a version of Gradle for ourselves, fix it, release it in-house into our own repository, and use that to iterate over our products much quicker without having to wait for Gradle to push their official change in. As a result of these bug fixes, we also happen to contribute back to the Gradle open source community in terms of pull requests and things like that. Also, we have worked very closely with Gradle Inc. to sponsor features that we felt were critical to success of Play on Gradle. And these features, we hope, will not only empower LinkedIn, but also the open source community at large. Let's talk a bit about the best practices that we have in place for Gradle. So we strongly recommend using Java 8 and not to use Groovy. Java 8 is just much more maintainable, more debuggable, and just works well at enterprise scale, like the scale that we operate at for LinkedIn. While developing plugins or tasks, it's critical and super important for us to make the tasks incremental. What does incremental mean? Basically, you can tell Gradle that these are the inputs for a certain tasks, and these are its outputs. Now, when you're running your builds, Gradle figures out if the inputs and the outputs haven't changed, and then it skips over those tasks. What this allows us to do is basically skip over tasks when they've already been run before, and thereby speeding up the builds by a factor of 2-3 times even. While we're making the tasks incremental, it is also really important to make them modular. You don't want to have tasks, we don't want to have really big tasks that does a lot of things. Instead, what you really want to do is decompose them into smaller tasks, each with its own specific work to do. And next, pushing with high confidence. What does high confidence mean? Basically, write a whole lot of tests. Make sure that the Gradle plugins or the tasks that you write don't have any side effects. And this goes back to testing. You not only test with the product that you're presently working on, but actually try it out with other applications so that your plugin might most probably be used with some other plugins that somebody else has written, and you don't want them to step over each other. And craftsmanship. Craftsmanship is like a key buzzword for us at LinkedIn. It's really, really highly stressed. What we mean here is that sometimes tools and infra get overlooked in terms of code quality. We don't hold them at the same standards as, say, production code. But at LinkedIn, it's really critical for us to basically ensure that each and every line of code that we write meets the production bar. Let's talk a bit about LinkedIn craftsmanship. So basically, since Play was quite ubiquitous in LinkedIn, we already had quite a huge ecosystem of SBT plugins. Now, when we had to migrate from Play from SBT to Gradle, we had to migrate a lot of these SBT plugins and create their counterparts in Gradle. While we were doing this, it was necessary for us to maintain feature parity. Whatever the SBT plugin was doing, we would do the equivalent in Gradle, if not slightly better. While we were doing this, we realized that SBT and Gradle can coexist. Like if you had an application that was being built with SBT, we could add Gradle components and tasks incrementally to the application without having to do one huge shift over from SBT to Gradle. We could add tasks incrementally, have them reside side by side without affecting each other. And this was really useful because it minimized the risk that we would encounter when moving from one application which was being built with SBT and then the next stage being built with Gradle. Fixing Gradle plugins. So LinkedIn also has a long history with Gradle. So there were a lot of Gradle plugins already in the wild, which had been created some time ago. They were using older versions of Gradle. Gradle has moved on. It has developed better features. These plugins were not really making use of those features. So as a part of this process, we also revisited those plugins, made them more incremental, more modular, and enable them to use the later versions of Gradle and the features thereon. Lastly, we stayed away from using the new configuration model. So this is something that we realized that we had to do, and we also recommend that you stay away from the new configuration model as well. So we avoided it as much as possible, except for the case where things like the Gradle Play plugin itself comes with a new configuration model. So only in such cases where we really had to use it, we started using the configuration model. But the good thing is the new configuration model can coexist with the old configuration model. So the plugins and the tasks, etc., that we have in Gradle are basically a hybrid of these two things. Well, that's it from me. I'll hand it over to Zach to talk more about some Gradle goodness.
Did I do it right?
Yeah.
Cool.
Slide it all the way right.
All the way to the left.
There it goes. Working. There you go.
Thank you. Cool. I know how this works now. Hello, I'm Zach. I actually work on build tools now instead of LinkedIn Learning. But that's like as of yesterday, so that's pretty cool. I'm going to show you guys hopefully some of the really cool Wowie stuff, because Wowie is nice. So these are metrics for builds and idea generation. So we typically use IntelliJ at LinkedIn. And I will say, we gave this to a few people, a few developers right off the bat, and the immediate response we got was, oh, holy shit. And that's kind of putting it lightly. You're seeing some of our builds here 2, 3, 4, 5 times as fast, and that's really what we were aiming for. And what you'll see in the red is actually the largest multi-product. And we actually noticed that there were some hindrances, some things that were slower than what we expected. So we actually deep dived into that. We looked at some of the dependencies. And actually, I think that last bullet really kind of keys it away for what's going on here. That multi-product, that repository is the largest thing, or one of the largest that we develop at LinkedIn. And we can hot reload that with a shitload of exclusions. And we actually ended up getting, what does that say, 90? Sorry, my glasses are bad. And we got 90 almost down to like 15, 20. 15, 20 seconds for a hot reload on something that today with SBT was not the most friendly. When Gary said 2-3 minutes, that is where the 2-3 minutes came from. So that was another for our developers, like a real holy shit kind of moment. And also idea import. I personally am a favorite of that. We have SBT Refresh. It's this nice little SBT plugin that we put in IntelliJ. And that caused that's probably the single biggest heartache, I would say, of this project. And it was probably the number one message that we kind of got as a team. We say, please, please, oh God, fix this one thing. So that, and when you refresh a subsequent dependency and it takes 25 seconds as opposed to, I don't think it says here, it would take like an hour for our largest multi-product. So that's kind of a relieving thing. It felt really nice. Oh, user feedback. I thought this was kind of funny. This is a lot of positive feedback that we got from our developers. And I didn't realize it until we put this slide up. My common response is to use a dance emoji whenever someone gives really positive feedback. So it's kind of interesting. But these are, some of our most senior, some of our really respected engineers in the company. And they say, wow, we're happy. We have the things that we want. Hot reload is fast. Dependencies are wonderful. We're not running into issues. So kind of, as a kind of a tools developer, these are really the things that you look for. Your happiness, in a sense, is directly correlated with that of others. So if you can really up-level other people, this is what we're looking for. And then migration. So Gary was not kidding. There are like 30 emails that say this. Please, oh God, we'll be your guinea pigs, whatever it takes. We'll join your team. We'll do whatever you need to get this working. It really was painful for us. And that's why we did this migration. That's why we're trying to provide this value. And kind of remarkably, once we got the hang of it, and we really had a well-defined tool set, the plugins that we created, everything that we had kind of jostled together, it was super fast. It was super, super quick to migrate our multi-products. We have this kind of once every month on Fridays, we have these things called in-days. So the thing I told our developers last time is, on your in-day, just give this a shot. I got, I think, 3 or 4 pings in our last in-day, and they say, oh, we migrated. I said, did you have any problems? Oh, no, it just kind of worked. So it was a very, very pleasant experience. And I'm going to be totally honest, I totally did not think that would have happened. Normally when you change the thing that everything builds with, you kind of run into a bit more hiccups. But no, that was not the case. And that's exactly, I think, one of the biggest takeaways for this migration. If you give someone a gigantic carrot, say this is the best thing since sliced bread, they will, there's no such thing as a horizontal, right? I think it's 30 plus today. It was like less than 20 last week. People are just all hands on deck to get this migrated. People are really, really attracted to this solution. And then the future. So the future, I think, is always the coolest thing because it's very inspiring. Obviously, we're going to get our largest applications fully fledged onto Gradle. We kind of have this like half and half thing going on right now. That's all going to be moved to Gradle. We're going to move to play front ends. And then obviously, I think it's been a super hot topic today is the distributed cache. So we're building our biggest repositories. And originally, it's 30 plus minute build time. It was not 30 seconds. I double checked it this morning, I'm sorry. But when you leverage the cache, you can clean builds, and now you're building that 30-minute gigantic monolith. You're now building it in 3 minutes, 20 seconds, and you say, oh, that's nice. That's a nice feeling. So, and obviously, we've been working with open source already. We love these guys. It's so much fun. Why not keep the good feelings going? So there's a lot to look forward to, and it's a really positive initiative. These are kind of a reiteration, but we'll go through them anyways. Just kind of summing things up. If you kind of inherit a custom build tool, when you say, oh, we should decide on this framework as an organization, well, punch that person in the face. That might not be a great choice. You know, there's a lot to be said when you adopt a whole nother thing to maintain into your ecosystem, along with the thing that's supposed to solve problems. So we kind of learned that lesson in a very multi-year kind of way. Rapid prototyping, top-down versus bottom-up. Get something built, run as fast as you can. It'll all break into pieces as you're going down the cliffside. Just reinvent the wheel every single time. You know, just constantly improve. The Play on Gradle solution that we have today will get like 5 times as fast, 2 times as good. It all just improves dramatically with time. I mean, Gradle works the same exact way, right? 1.0 is not nearly as shiny as 2 or 3 or 4.0. Gradle being Gradle. Gradle's beautiful. You know, you guys use it. I don't have to sell you on it. You know, it's really sexy to kind of simplify your build logic into, you know, 50 lines of code. Cross-org teams. Vinyas is from our flagship organization. Gary's from presentation infrastructure. These 2 guys are now on my team. I was from not on that team. You know, it's really great to just go up to someone and say, hey, I think this is a good idea. Can we build it? Can we get it done? And they say, who the hell are you? Okay, sure. And that's really how it worked. You know, when I joined, they kind of looked at me and they asked, well, what do you do? And I said, well, this now. You know, and getting that consumer feedback, I think, was really, really valuable for our team. Oh, and lastly, pragmatism. Is that how you say that? Pragmatism? That word, which in English, you know, hopefully more people than me know. It's okay when things go wrong. It's okay when, oh, I have to fork. I think we forked Gradle 2 or 3 times when we kind of just ran into bugs. You know, we service, I think, in Gradle itself services to like almost 4,000 repositories at LinkedIn. Okay, that was a yes. So that number is roughly correct. And so, you know, you can't be something like, oh, let's just go upgrade everyone to the latest version of Gradle. No, that takes a significant amount of time. You know, it's a really big investment. So really getting those kind of tactical fixes in and making that fast iteration cycle is what was really valuable for us. And that's it. The most important bullet here is obviously at the bottom. You, question mark? Yes, we are hiring. So if you guys have any questions, any concerns, or if you just like smiley emojis, I think we can go back to the slide with the SPT operations. So, are there any questions? Cool. Oh, yes.
I have a quick one. I'm just curious how you measure the build performance gain between SPT and Gradle.
Build performance gain?
Yeah, you showed a table with a bunch of numbers with, you know, these various tasks were yes, that.
That one?
Yeah, how'd you generate those?
Essentially take a repository. There's this like preparation phase of delete the everything, have a fresh checkout of X repository, run clean task. Rinse and repeat 20 or 30 times per number. So, cool.
Have you guys used or played with Lagan framework for Play?
What? What did you say? Sorry, I cannot hear.
Have you used a framework by name Lagan?
Lagon? Lagon.
Not yet.
Oh. Lag on, lag off? Is it? No, I don't think. But let me know. I sit right there. You can come tell me. That'd be interesting. Cool. Anything else? Oh, thank you.
Thank you.